created some of the most successful planes in aviation history. 50 years ago, they produced this plane, the first of a new generation of jetliners, the 707. Over the following years, they gave the world's airlines plane after plane. Relentless succession of sevens, they produced the 727 and 737, followed by the 747, the famous jumbo, and more recently, the 757 and the 767. Now the company has decided to add yet another plane to the stable, the 777.
It's time. The world is ready for a new airplane. An airplane that will take us into the next century. Designed and built by people empowered with forward-thinking ideas. By a company that knows the airplane business inside out. Introducing the Boeing 777.
Each week, there's a chance for some of the 10,000 people involved in the 777 project to meet senior Boeing managers. Today, they get an explanation of why the world needs a new Boeing airliner from Alan Mullally, Vice President of Engineering.
The airlines of the world told us they wanted an airplane bigger than a 767, but they wanted it smaller than a 747. And we said, why don't you buy 767s? They said, we want an airplane that's bigger than a 767 and smaller than a 747. So we said, well, that costs a lot of money to make a new airplane. And of course, you know what they said again. We would like an airplane that's bigger than the 67 and smaller than 4. You know, satisfying your customers is really hard work. Do you know who Bob Crandall is? He's the chairman of American Airlines. And it's really important that we make an airplane that Bob Crandall really likes. And he loves the airplane. What do you think he doesn't like? The price. A lady over here said the cost. Bob Crandall doesn't care about the cost. Isn't that something? We try to explain it to him. And he says, here's a quarter. Call somebody that cares. And you know what else he said? Airbus was just here. We just talked to him again
Mullally doesn't
yesterday.
need reminding that there are two competitors for the 777. There's a new large plane from European plane makers Airbus and another from McDonnell Douglas. Boeing needs to stay in the race.
If we didn't do anything, somebody's going to do something that'll fit that need. Obviously, from our point of view, in that sense, yeah, it's a Boeing need. If we want to continue to be the force in the marketplace that we have been, we need to be where the market needs product. You can always forego a market segment, but if it's an important one and you forego it, then you're leaving the company at risk.
But making the 777 is also a risk. It's a $3 to $4 billion program, and the plane is the world's newest and most advanced airliner. Nowadays, building a modern airliner is an international enterprise. Although the 777 will be assembled at the Boeing plant in Seattle, many of the components begin their lives with a whole range of subcontractors all over the world. Some pieces of the plane's skin, as well as passenger doors and some wing ribs, will be made in Japan. Parts of the tail, including the huge rudder to steer the plane, come from Australia. Nose cone and flaps are made in Italy. The choice of engines comes from 3 different manufacturers in the US and England. Landing gear from Canada, France, and the US. Some of the electronic systems from England. The nose landing gear door from Belfast. And the rest of the tail, the wings, the nose section, and remaining parts of the plane are made by Boeing themselves in the United States and Canada. The Boeing company is based in Seattle, in the northwestern United States. Commitment to the 777 has meant building a huge new plant at Everett, to the north of Seattle. Boeing has promised its customers that it'll start deliveries of the new plane in May 1995, although at the end of 1992, it is not even fully designed. In January 1993, this plant will start to assemble parts of the first few planes on one of the world's largest tools. When this giant rig is working, it'll be capable of assembling the wing spars for one plane every 3 days. To get an idea of how big the 777 will be, here's a smaller Boeing plane, the 737. Like the 777, it has 2 engines, but there the comparison stops. The 777 looms over the 737 when they're side by side. Its engine is the same diameter as the body of the 737. And the horizontal stabilizers, the flat parts at the back, are almost as long as the wings of a 737. The 777 will still be smaller than a 747, although after 25 years of improved technology, it will have almost the same capacity and range as the first jumbos. With previous Boeing planes, a full-size mock-up like this 747 had to be built during the design stage. It's a plane that never flew, complete in every detail. It was the only way to ensure, before going into production, that all the parts fitted together. To design and build the 777, Boeing have switched to a pioneering computer-aided design method using 8 powerful computers, the world's largest collection of mainframes hooked up for one purpose. The system is called CATIA, and it contains precise descriptions of every structural component, every duct, every wire, every single fastener inside the computer at life size or larger. It's called a digital mock-up because it allows pieces to be moved around, changed and checked to see that they don't interfere with other pieces. What used to be done with a full-size physical mock-up. CATIA is part of a major change in plane making. That means that engineers share the design task with the manufacturers instead of finishing their drawings and then passing them on, as they used to.
The old throw it over the wall business of, you know, here's what I insist be the case. Now, do what you can with it. That's gone away. But in order to really make it go away, you still wind up throwing it over the wall. You just have to accept it when it's thrown back, and that's the difference.
The bane of every designer's life is when one of the parts he's designed gets in the way of a piece designed by someone else. But with CATIA, any interference between 2 parts shows up in red.
I do indeed have a little problem here, but it's a very small one. We haven't released any drawings yet.
Here we go with the stresses in the model in this particular area. What I did was zoomed in right here.
These designers have discovered that one of their components is thicker than it needs to be in certain areas.
And you can see in this area, we've got some low stresses. And
using the CATIA system, they create a hole in the piece and save some weight without changing its function. The system now recalculates the new stresses to show that they're within acceptable limits and works out how much metal will be removed if the hole is made.
So here's -1
In a plane that weighs over 500,000 pounds, the weight reduction, about 1/5 of an ounce per door, will still make a useful saving. The 777 will be powered by 2 large engines. With the increase in power and reliability of jet engines over the years, there are safety and cost advantages in having 2 powerful engines rather than 3 or 4 less powerful ones. The engines will be tested on the ground in 3,000 simulated flights, several engine lifetimes of in-flight activity. Even if one engine fails, the 777 will be able to fly on the other for up to 3 hours, allowing the plane to be scheduled on long routes across the world's oceans.
As far as flying over water in a twin, I'm very comfortable. The airplane can fail an engine on the runway, and it's either going to stop or it's going to fly. I mean, we designed it to do that. It can fly en route on one engine. I've probably spent hundreds of hours in these kind of airplanes on one engine. So I'm not concerned about that.
The job of a jet engine is to suck, squeeze, burn and blow. Air is sucked in and compressed by these blades. Then it's heated to high temperatures by oil burners. Most of the air rushes out at high speed, while the rest turns turbine blades which drive the compressors, helping to suck more air in. Each 777 engine will generate a thrust of up to 84,000 pounds.
MCD that I've come across, which only has one ring on the shaft.
Some of the 777 engines are being made by Pratt & Whitney. Today is a special occasion when maintenance engineers from the companies that will buy the plane give their views on the current engine design while there's still time for final changes.
I'm not sure if that's a
The engineers will be allowed to swarm over the engine, poking screwdrivers, spanners and torches wherever they like, to see whether, on a wet and windy night in Tokyo or Chicago, it'll be possible to remove a particular part, several layers deep in the pipes, tubes and cables.
This is another thing we've had trouble with over the years have been these captured fasteners. And, you know, when you're outside at midnight and it's 10 below zero and this thing falls out and goes through a sewer or something, you go try to find another one and it's not, well, I've always wondered why they couldn't just put a bolt in there, and it'd be so much simpler for us.
Is this muscle fuel here?
No, here, let me show you right here.
Is this muscle fuel or this meter fuel?
See, what you don't want to do is have to remove the drip shield, really, to drain this. Okay, you'd like not to have. Just one more thing you've got to do. It's going to take that much more time.
So you're just saying like a petcock with a tube on it?
With a tube on it. That's what I said. That's what I think he's.
Petcock somehow.
That's right. That's what I think he's talking about.
You can see over here the olive shape. That's our new seal.
The thousands of people who design the plane are organized into about 230 teams called design-build teams. For the first time, Boeing has included representatives of the manufacturers in their design process.
This shows more detail of the corner
This team is responsible for designing and building the passenger doors, which are to be manufactured by a Japanese company.
We've asked the cutout people to go
when
and
it comes to
revise
discussing
those
schedules,
sculpted
materials, or
surface
manufacturing methods,
But what's
the
happened is they
manufacturer's
said that,
input can smooth the transition from
Japan.
drawings to factory.
And
In some ways,
they say this is the
design-build
best that
teams
the,
are a reminder
engineer
of
can do.
earlier plane makers.
If you go back to the early airplanes that Boeing built, the factory was on the bottom floor, engineering was on the upper floor. Both manufacturing and engineering went back and forth. When there was a problem in the factory, the engineer went down and looked at it and said, well, you better do this. The entire design department was within 50 feet of each other. As the scale went up, that gets harder and harder and harder.
The fresh approach of the design-build teams means that every component of the 777 has benefited from a design rethink.
The traditional Boeing doors, actually, they come in and twist sideways and go out the whole sideways and invert themselves. And what we found on this new airplane program is that the forces to do that are kind of getting up there, especially on a door as big as this. And we thought we'd look at a new door concept. On this concept, all of the weight of the door is hung on this hinge, which is bolted to the airplane. And the loads are vertical, so the hinge can take all the load. If you can understand, if this were tilted like so, you'd be pushing the door uphill, so we don't have that problem. And we have some simple and efficient bearings, so the total load to push the door is actually quite small and can be pushed open with one finger.
In the early stages of door design, Gaffney realized that with 8 doors on the plane, each requiring about 1,000 separate components, it would make sense if each door could have as many parts as possible in common with the others. But that wasn't easy.
What we recognized early on was that the key to make all the parts common was to make the hinge common, notwithstanding the shape of the body was different. And I put one of my best guys on it, put him in charge of hinges, and asked him to go research and come back and show me how they can be common. He came back after 2 months and said they couldn't be common. I did a little management ploy. I said, fine, who do you recommend to follow up on this, and we'll let him give it a try. And with that, he said, well, maybe there's something else I can look into. And lo and behold, it took him another month, but he had that dedication, and he pulled it off. Unfortunately, after he was done, we changed the contours of the airplane for better aerodynamic performance, and he had to go back and do it again. But he knew he had done it once. The second time around took him about 4 weeks, not 3 months. Then, of course, what did we do? We changed the contour again. But by now, he knew the techniques to use, and he got the hinge to catch up in a week. And that was the key. Right now, not only is the hinge common, but all the mechanism is common. Indeed, 98% of all the mechanism of the door is common. So it was a critical design discovery, a critical design implementation, and fortunately, the guy had the smarts to pull it off.
Although the 777 is over 50% heavier than the 767, these new techniques mean that in man-hours, it'll take about the same time to build as the earlier plane.
We found out that a lot of the cost of the airplane was not in building it, but in rebuilding it and rebuilding it until we got it right. So when we started off on this new door design, I and my crew went up to the Everett, where the last airplane was made, the 767, and we went through all of the changes that happened on all of the doors on the 767. Matter of fact, we looked at 13,341 changes, cataloged them as to what the cause was, but more important, we looked at the new initiatives we've got on this airplane program, and we picked what initiative would solve that problem, would obviate that mistake, would make that mistake not happen. We also assigned a dollar value to that mistake. On doors alone, according to our assessment, $64 million was spent just in changing the design. And we felt that if we applied the new initiatives in the order that these costs come up to, we could save all of that money on these doors.
100.
This is how the 777 cockpit will look, glowing with new liquid crystal display screens. Pilots will undergo a conversion program in a simulator like this to teach them to fly the new plane. And John Cashman, the 777's chief test pilot, is helping the designers to make every detail as user-friendly as possible.
That's where people are going to be rubbing the forward edge of the panel.
It may seem an unnecessary level of detail, but giving a control knob a definite feel of being on or off can be an extra source of information for a busy pilot.
Hopefully it feels better in positive response, but it's just a little backwards in the way it... What do you think? Is that acceptable? Or
if you do it slowly, you hardly tell the difference. If you do it fast, you can feel it. Are all the letters the same size, height?
Same height, yes.
Do they have to be?
Well, I'll get my bag and we'll swing back there. Okay.
Cashman is responsible for all the 777 flight tests, and he'll have the privilege of being the first pilot to fly the first 777 in 1994. He and his team of test pilots will also take the plane through a grueling series of maneuvers that check how well the plane will survive in extreme conditions. But those flights are 18 months away. For the time being, since the 777 doesn't yet exist, he's currently getting flying time on a Boeing 757. It's part of a program to try out the new flight control system that will eventually be installed in the 777. The 757 is a much smaller plane, but it's been adapted to use the 777's electronic system, called fly-by-wire, for carrying the pilot's instructions to the flaps, rudder, engines, and so on. During today's flight, they'll be carrying out a number of takeoffs and landings to feel how the plane settles into its landing position with the new controls.
I remember what we saw in those early flights. I don't think it was that high.
No, they said 65, 70 pounds at the most, and I had 105 pounds.
Yeah.
The plane has been converted to dual control, the fly-by-wire system on the pilot's side, and the 757's own system controlled by the co-pilot.
The main differences are some of these little instruments that are put on here, and the biggest difference for fly-by-wire is this and this. This is actually what turns the computer on and off for fly-by-wire.
Flight instruments 3008, parking brake, fly-by-wire system.
The 757's own controls use the traditional system of cables and pulleys stretching the length of the plane. The joystick pulls on the cables to trigger hydraulic devices that move the wing flaps or the rudder. Fly-by-wire replaces this cumbersome physical system with electronic signals and uses computers to adapt and interpret the signals to give smoother flight and more responsive landings and takeoffs. 11 engineers go along for the ride, monitoring all the systems on their computers. They've just taken delivery of some new software and are trying it out for the first time. The engineers and the test pilots will be concerned to see that the plane under fly-by-wire handles in a similar way to conventional control systems, even though many of the decisions will be taken over by computer. It's partly to make sure that pilots who've trained on other aircraft won't find that the 777 feels too different when they fly it.
Didn't scare ourselves today. IRS is a lot of landings. 20. Yeah, that's a good set. You got 20 landings today. Yeah. One of these days I'll get it right. John was a big fan. Say, we keep doing it until we get it right.
The post-flight briefing reveals that today's tests came up with no unpleasant surprises.
Okay, we can get started here. Post-flight test 3-31 today on NB-143. We flew 3 hours and 21 minutes airborne time. 4 hours and 15 minutes was our block-to-block time. We had 2 crew changes today. Made 20 landings. 19 of them Moses Lake. The final landing back here.
What did you think in general of the flap compensation and the pattern today?
Near great. Frank and I both were commenting on it, that it's really nice, and it does.
Between March and September this year, Cashman and 44 other pilots completed nearly 600 landings on the 757 fly-by-wire rig. The next time he will get his hands on the system, it will be installed in a real 777. On a hot July day this year, it's 50 degrees below freezing in Boeing's environmental test chamber. The passenger doors team are ready to see if their door will perform under extreme weather conditions.
If the plane lands from a cold flight, minus 65, and comes into an airport where, let's say, it's about 28 degrees, there's freezing rain, and it pulls up to the gate, and this freezing rain is then adhered to the outside of the airplane, we need to make sure that we can open the doors. Our criteria is a 1/4 inch thick of ice all over the whole airplane. And yet, at the same time, someone with nominal handle force on the inside can indeed open the door.
Technicians start spraying the outside of the door with water. Working in shifts, they'll spray throughout the night.
Welcome to the Bahamas.
Early the following morning, the engineers are ready to see whether the door mechanism can overcome the effect of a thick layer of ice. Test regulations say that the door should open easily even when it's sealed by a 1/4 inch layer of ice. But they've never done this before.
was formed after the bar was down.
That's great.
It'll show up automatically.
Boy, it's nice. This is a big key test, and it worked great. I feel real good about it.
George has been working hard with
A constant preoccupation of the 777 team during this year, analyzed at meeting after meeting, has been the quest to reduce weight so that the plane meets its target promised to the customers when they place their orders. Every section of the plane, from cockpit to rudder, comes under close analysis. Every ounce helps.
Okay. Very good.
I've been gone, Bailey. How did we get down to here on the way? What was the good news?
Rudy took weight out. George took weight out. Everybody took a little weight out.
Rasmussen took weight out.
Yes.
Elbon took weight out.
Hold it down here.
Right.
That's good.
But we got to keep going.
Got to keep going.
Got to keep going. We're on a roll right now.
This is one of the regular meetings of all the 777 chief engineers.
has given us low.
With a brand new plane, every detail has to be open to scrutiny by this roomful of the world's top airplane engineers. This meeting lasts 6 hours and still runs over schedule. Constant, frequent communication, punctuated by moments of boredom, seems to be unavoidable.
And that's the part that bogged my people down for a long time, and I didn't understand. So the overall load is there, and I think we understand it. The stress understands it. But if you look at one little particular part and want to know how much load is up on that through all the paths, nobody's got the information. But they're working on it. So, well, we've got to have some logical way of saying this is about what it is that we can show to FAA. And
Pressure to get the costs down also dominates the meeting, but it mustn't be allowed to jeopardize the safety of the plane.
When we look at a trade, or what is apparently a trade between safety and economics, it very rarely is a black and white issue. You look at it with a lot of things in mind, and you do it as carefully as you can. You try to back up, I will say, to the most fundamental issue of all. Most basic, of course, being is if you don't crash, then you don't have to worry about how airplanes survive crashes. And so the highest level of attention goes into those set of issues. What are the things that cause crashes, and how can they be prevented? And I can't off the top of my head, and I don't think, because I think it's the way it is, I can't recall a place where at that level we made an economics versus safety trade. Now you get down into, well, what happens if you had an accident, and could you make the airplane safer? Doors. How many doors should an airplane have? That's clearly a balance. I can put a door on every row, and clearly getting out of the airplane would be easier. On the other hand, it would be so heavy that it either wouldn't fly or couldn't carry anybody anywhere, and is a non-useful vehicle.
Condit gave us that interview earlier in the year before the 747 crash in Amsterdam last month. His colleague, Alan Mullally, gave the 777 team's reaction to that event.
The effect of any accident or incident on a team, on the Boeing team, the reaction is always of what happened, what exactly happened, and what does that mean to us designing airplanes. And it starts with the existing airplanes. Whatever airplane got in trouble, whether it was an airplane problem, an operation problem, caused by the environment or the weather, our number one reaction is what happened and what can we learn from it and what should we do right now on the existing airplanes and what does that mean to future airplanes. So in a way, it frustrates us deeply that we can't find out more quickly. And we have to be very careful ourselves not to jump to conclusions. And we feel the same anguish and pain and frustration of wanting to know right away so that we can make it okay. We can make that next design solution, if that's what's needed, more robust, better, not have that happen.
One morning in June, Mullally and Condit join their 3 colleagues who make up the 777 management team for a weekly top-level meeting at 7 a.m. They're all Boeing vice presidents, and it's called the Muffin Meeting, because their team manager, Phil Condit, supplies his colleagues with breakfast, his wife's homemade muffins. At their meeting today, a particular issue comes to a head. It's to do with one of the new materials that has been selected for certain components in the plane. The material is a new lightweight metal alloy of aluminium and lithium. There's not a lot of it in their plans, but what there is saves a useful amount of weight. The trouble is, it turns out that it's difficult to drill holes in the alloy without producing small cracks. At the Muffin Meeting, Mullally tells his colleagues what he thinks.
This is really a toughie. All things being equal, I would like not to pursue aluminum lithium. When we originally tried to develop this new material system, we did it for all the right reasons. We did it because we thought it would save weight. We thought its fracture toughness would go up. We thought it would be more durable in service. We thought it would have wide application. We thought the customers would get a lighter airplane and more efficient. And at the time, with fuel dominating the cost structure, those all seemed like a good judgment. The world's changed. It's expensive. The prices aren't going to change. This is a boutique material system. The competition between Alcan and Alcoas and everybody didn't develop. The prices are still a lot. The downside risk is that in some of the areas where we have it, like in the ribs, in the wing, if we ever had a problem, with any new material system, the exposure to the airline and ourselves to fix it up are huge. So it seems to me that it's not in the best interest of all to pursue aluminum lithium now. Problems in River City.
Mullally has decided to call a meeting of the most senior engineers concerned with this issue. They have to make a decision. Either way, it will be difficult. If they go with the metal, which Mullally and his colleagues know is safe, they risk future trouble from customers who may not believe them. If they change to another material, there's a lot of new design work needed when things are already a little behind. There's also the problem that they'll have to switch to a heavier material to replace it, thus losing some of the weight improvement of previous weeks.
Okay, first of all, just a little background, and I'm sure this is probably pretty well understood for everybody. When this program entered into a weight problem very early on, we got together with the weights group and pitched aluminum lithium for secondary structures. Said it's going to be used in areas where we think the risk is relatively low. We've got to be careful about how we do this. And so we turned them on to go do that.
The group discusses the issue for an hour, wavering back and forth on whether or not to cancel.
Taking a cross-section through here to show what the defect looks like. This is at 2.8 thousandths of an inch interference.
So my impression from what you said is that if we keep any of it, then we'll have to do a lot of things to work it.
Oh yeah.
The issue we had with aluminum lithium is that for the applications we were using it, the cracks were okay. Technically, the way the part was going to be used, the crack wouldn't grow, but you could see the crack. So how would the customers feel about that? They could see the cracks. Now we'd have to say, on these parts, Mr. Airline, the cracks are okay. And they would have to figure out how to communicate that to all the people that interface with the airplane. So it was a concern, because it would mean extra time, extra notes in the maintenance manual, extra notes in the operations manual. It's okay on this part, but it's not okay on this other part. We consulted with the team. They felt like we could get some more weight out, so we decided to remove the material.
But this decision, so late in the day, just added to the pressures on the engineers, who were being pushed by their bosses to complete the designs.
One of the most challenging things about being in engineering is it's never quite good enough. If I just had a little more time, I could make it better. If you'll let me work on it for another day or two, I can definitely improve it. And so the challenge is to figure out exactly when we should stop designing and release the parts. Neither too early nor too late. If it's too early, we'll fix it on the factory floor, and that's expensive, and we don't want to do more than that than we have to. If it's too late, we don't have an airplane when United expects it in May of '95.
United Airlines were the first to order the plane, and their order triggered the go-ahead for the project. Like the other principal customers, they've played a major role in the design process, unheard of with any of Boeing's previous planes.
And this was entirely new, to have them actually sit here with us every day and know all our secrets, and we know all their secrets, and be completely open. And it was very interesting, because there was a lot of nervousness inside Boeing. You mean, the airline's going to sit in our design build team meeting? Yes. What's their job? Well, their job is to bring their knowledge as an operator of airplanes, because they know a lot more about operating airplanes than Boeing does. And maintenance procedures and reliability issues and things like that. What materials work, what don't in service.
One of United Airlines' contributions to the 777 concerned a flap made of carbon composite on the back of the wing.
It's a beautiful flap. It's 43 feet long, but our autoclave that would do the repairs on this is only 25 feet long. So our math quickly told us that if you put this thing in the autoclave at United to apply the heat and pressure you needed to fix it, couldn't close the door. And meanwhile, Boeing was building a 60-foot long autoclave, and they had no problem with it. So we said, you know, you've got to either break this flap in half so we can fit it in for repair at some date, or at least make provisions to have us saw it conveniently down the dotted line so we can get it in someday. And that's what they did. They actually beefed up the honeycomb inside the flap to permit us to, if we ever had to, saw through there, make a repair in our short autoclave, and then put it back together with a splice. You know, not the best looking thing, but it'd be a lot better than if they spliced it originally and flew around from day one with a big two-part flap.
Another of the airlines had a much smaller worry than a 43-foot flap, but to them just as important, a problem in the lavatory.
By talking more to this airline, what we found out was really on their mind is that in flight, in the lavatories, when a toilet lid or a toilet seat falls down in the toilet bowl, it makes what they called the big hit sound, the big bang sound. And they found that that was very distressing to the traveling public. So we went to work. We got the mechanical designers, the electrical designers, and the toilet suppliers and makers of toilets and toilet lids, and we got them together, and we started to work on a small device that we could put on the back of the toilet lid. You can see this device right here. And this little device could go on the toilet lid, and we could put another piece out the other side that could hook onto the toilet seat. And we could absorb the energy of the toilet lid and the toilet seat before it hit the toilet bowl. Now, that's a neat invention, but that's the first step. The second thing is it needs to work all the time. We don't want it stuck open, and we don't want it stuck closed, because that could be even more irritating than the big bang sound. So we tested it. So we got some prototypes, and we made with our suppliers, we made a toilet seat that we could automatically open and let the lid and the seat fall. And as of last week, we have completed 670,000 cycles of this toilet seat going up and down, and we have got it down to 0.7 of a pound for each device, and it's reliable, and it looks like it can be installed cost effectively, and that's what airplane design is really about.
On August the 31st, Mullally and Condit had something new to think about. The board of the Boeing company set in motion a chain of events that started with Condit.
I changed jobs. That's something I've done more than once in my career. On the 31st, I got elected president of the Boeing company.
I was called in by the bosses, people I respect and work with, and they told me that Phil was going to be the president of the company. And I was really excited that Phil was going to be the president, like everybody else. So I leaped from my feet, reached across the table, grabbed his hand, and said, "Congratulations, Phil." Leaped across the table the other way to Dean Thornton, who now works for Phil, who Phil used to work for, and shook his hand and said, "Congratulations, Dean. Great choice on picking your boss." Then I sat down to get ready to leave, thinking all the time that it was really terrific that they would take the time in their busy day to let me know that my boss had been promoted. And with that, they said, "And Alan, we would like you to manage and continue to lead the 777 program." And my reaction was, "What? I'm really busy."
One of the many things that was keeping Mullally busy was a major component of the plane being manufactured in Australia by a company called Astor in Melbourne. Astor had the contract to build the rudder on the 777. The rudder is a movable piece that stands vertically at the back of the tail. It needs to sustain strong air pressure across its surface as it moves from side to side to change the direction of flight. Astor has an October date for baking their very first 777 rudder in a large pressurized oven called an autoclave.
It's a bloody big job.
It's a very large component, bigger than some airplane wings, and made of layers of carbon fiber over a honeycomb core. Earlier in the year, there had been some concern about potential vibration problems, and the rudder team in Seattle has now decided to change the design of the rudder. For the Astor people, it's very worrying.
We'll be running all kinds of extensive tests, and they'd find out that the first one was, for instance, it was a harmonic vibration, basically, and to dampen that, they put on some counterbalance weights. This one, they needed some additional load stiffness in the rudder, and they've increased the thickness of the plies on a panel like those, the two skin panels, and some of the internal structure of it.
Don't hit the bloody thing.
The patience of the Astor manager in charge of the project is sorely tried.
I was cheese off the blazers because of this change, and I'm not exactly that happy today because we set out to achieve a whole series of things with this particular rudder, the skin. We'll achieve most of them, but probably the thing that worries me a little bit is that the configuration will change, and it's going to change fairly dramatically, and we still have to deliver on schedule. We've got a requirement to deliver this rudder in the middle of next year, and if we're late on that, it puts Boeing in a bind, and we don't want to do that if we can possibly avoid it.
At this stage, before baking, the material of the rudder on its rig is soft and pliable. After baking, it'll be as solid and as tough as aluminium, but much lighter, if everything goes to plan. The rudder is to be baked at a temperature of 177 degrees centigrade for 7 hours. These thermocouples are temperature measurement devices, being installed all over the rudder to make sure that every part of the rudder skin reaches the right temperature for hardening and toughness. It's the first time they've baked such a huge piece, and evenness of cooking will be essential. Over the weekend of October the 3rd and 4th, the rudder is baked and left to cool. Then, the moment of truth. It is ready to be wheeled out, covered in its plastic bag and paper coating. The key question is, has it retained enough of its intended aerodynamic shape with the required accuracy, a few thousandths of an inch? Surveyors' instruments, theodolites, are used to measure the exact position in space of a series of target reference points. Some of the points that the engineers thought might have moved from their original position have hardly changed at all.
So the Z's moved bugger all, there's one we hope, so they must have pushed that back down again.
But there's a problem. As the computer data from the baking become available, it turns out that 4 of the most crucial thermocouples have not worked.
Hand it to the Unidexter.
The thermocouple problem doesn't seem to have affected the shape, although they now need to look at the other side, a task that requires a coordinated effort by the whole team.
Bit more support. Take it straight down.
Do you want that edge over the edge?
Yes. We're just getting a kind of a pretty picture of it right now.
then you get it all trimmed off and you can index everything carefully. It looks pretty good. I'm still nervous about it because I've got to make sure that the shape is right. So when we get all the trim off the edges, lay the templates on there, I'll probably sleep a little better.
On the 29th of June next year, we will be matching the tab to the rudder in a final assembly, and we'll be packing
The following
them
day,
to the States.
Tyler
I think it
addresses his
flies
group
on
of
the,
workers in a generally
17th
optimistic
of
way.
October 1994, I think is the date. So we've been on this for a while, but we're going to achieve those dates one way or the other, even with the design problem that we've currently got, which we're still going to work. All right, thanks, fellas. And if we could just, some of us have got to stay here for another little session, so the rest of us can all leave.
But with his more senior colleagues, Tyler makes no bones about his annoyance with Boeing.
Okay, look, now we've got rid of the rest of the team that participated in building the skin, what we really have to address is quite clearly the effect of all these changes that have been brought on to us by Boeing. Lovely company though they may be, they've given us a real problem insofar as building this rudder to schedule. And really, it's a pain in the neck at the present moment because we've said we must have that engineering by the 1st of November to give it to the subcontractor. Yeah. But let's assume we're not going to get it. What can you do to achieve it? Because sure as God made little apples, we're going to be late.
Have they given you feedback on our letter to them and telling them how we'd be able to save the schedule?
Apart from what I believe is some maniacal laughter on some of our requirements, no, they haven't really.
After the meeting, Tyler phones Boeing to report on progress.
And it's something that I'll get to you so that you can shoot it into Pete Van Vogt.
His main contact there is not pleased to hear about the broken thermocouples.
Next time you might want to test them first.
Well, we did.
Test the part.
We did. That's the problem. And the reasons why it didn't work is something we've got to finally determine.
You know, it's not going to be easy, but you know, we do it right. I think we can get there.
We love you most of the time, but in this case, we don't love you as much as we should.
A week after the mixed results in Australia, the Seattle team responsible for the tail of the 777 meet to discuss the events.
Begin evaluating the spar changes, and then I'm going to head down to Australia and face the teeming masses who aren't happy with this. What we're playing with really is the comfort level of the people involved. Calculating these stiffnesses is kind of black magic.
For the members of the team in Seattle, it's just one among a number of pressing problems. But for the Australians, it continues to be a major headache.
Okay.
Hello. Now, this is the first class section.
In the white heat of designing the plane, some of the 777 team still find time to think of the customers, the airlines who buy the plane, and the passengers who'll fly in it. With Alan Mullally's new responsibilities as team leader, he had to forsake engineering for a day last month and act as tour guide to Lord King, executive chairman of British Airways.
Now, Lord King, sit down here, and I want to just point out a couple of impressions to you. One thing that British Airways
The seats are real, but the rest of the interior is a mock-up of wood and plastic, costing $2.25 million.
Now, how about we let's move on back.
Thai Airways came in here one time and they saw this 7 abreast and they said, geez, you know, if you put 8 abreast in here and you put 7 rows in here, we can have 45-inch pitch.
And some people, they believe they like this space better than your personal space out. Because I believe you have enough here, especially for long flights.
Long flights is a key.
Where they can tilt you up.
And it's totally revenue neutral to us. I mean, it's 56 seats, one way or the other.
Okay.
Right, let's look at the back.
Where the passengers travel. This right here is bigger than the 737s and the 757s because that 10 abreast that we put in the back, we decided that you thought that the 5767 was an acceptable level of comfort. So another reason for picking the 5 inches is that when you put 10 abreast in the back, those are the same seats that you have in all of everybody has in their 37s and 57s, and everybody's accepted that and they feel that's good. so they're not going to feel like anything was taken away from them. And so that flexibility is really the key. Then you decide, let British Airways decide by the market each year.
It'll be more than 2 years before BA and the other customers take delivery of their planes. The hectic pace that the team have experienced this year can only get more hectic as manufacture and testing begin in earnest to ensure that the 777 will be delivered on time, on budget, and at the right weight.